Please.
I think we'll be seeing more. So good morning, everybody. Good morning. It's good to see the early risers in the Columbus community. It shows the people who are really thirsty for knowledge, or caffeine, or some combination. The knowledge, at least, will be caffeinated. I'm Peter Shane. As those of you know who were here with us last night, I chair the board of editors for IS, a journal of law and policy for the information society. I'm delighted to welcome everyone, both in the auditorium and online, to the first full day of our conference, Big Data Future. As I mentioned at last night's keynote, this symposium is the fruit of a wonderful collaboration at Ohio State involving our College of Law, our College of Engineering, and the Glenn School of Public Policy and its Battelle Center for Science and Technology Policy. And it also launches a celebration of the 10th anniversary of IS, which is the conference's sponsoring journal. IS was founded in 2004 out of the conviction that problems at the intersection of law, policy, and information technology would be among the very most important challenges we face, whether as scholars, professionals, or citizens, in understanding our nation's future, our world's future. And no phenomenon, as I said last night, illustrates this truth better than the big data phenomenon. Beginning with Joel Gurin's talk last night and extending today and tomorrow through 8 panels, two more featured speakers. I'm just anticipating mispronouncing what I'm about to say, which is the Pacha session over lunch. We have assembled an exceptional multidisciplinary group of experts to offer what amounts to really an extraordinary crash course on the big data phenomenon. What does big data mean? What techniques of information acquisition and analysis are involved? What great things might big data help us accomplish? What problems might a more data-centric society encounter? What kinds of investment do we need to get the maximum benefit from big data? Do we risk putting too much faith in data? What will our data-infused future look like, and what does this mean for lawyers and policymakers? These are the questions, again, I mentioned last night, and they will dominate our discussion, I think, for the next 2 days. Our time together will give us a wonderful introduction to all of these issues, and the papers from this conference will fill 2 special issues of the IS Journal that will be published during the next academic year. Also, as I mentioned last night, there are many people to thank for making this conference possible, and I would be remiss not mentioning them to this audience, which of course will include many people who were not with us last night. The faculty team behind Big Data Future includes Professor Jennifer Evans-Cowley from Urban Planning and Engineering, David Landsbergen, my lawyer colleague from Public Policy, Beth Ann Schilke-Leach, who's also from Public Policy, Karen Lewis, who's in urban planning and over at the College of Architecture and School of Engineering, Arnab Nandi from the Department of Computer Science, and Carolyn Wagner from the Public Policy School. The two individuals who've done the most to organize the logistics of this complex undertaking are Julie Keyes, the third-year law student who is the IS Journal's events editor, and Kelsey Chandler Nelson, who serves as administrative assistant to the Battelle Center for Science and Technology Policy at the Glenn School. I want to thank them and all of the wonderful student volunteers who've been helping us, and I also want to thank in advance the extraordinary group of speakers, each of whom leads a very busy life and has been very generous in carving out time to be with us today. Big Data Future wouldn't have been possible without a generous grant from the Battelle Endowment for Technology and Human Affairs. We received financial assistance also from the College of Law, its Center for Interdisciplinary Law and Policy Studies, the OSU Student Activities Board, the College of Engineering, and Elsevier, and we're deeply grateful for all of these sponsors. And I'd like to mention again, as I did last night, that the reference staff of our library has not only created a display of literature relevant to big data that you can see outside the library, but they put together a big data research guide if you want to read more about these topics. It's available online, and if you want a hard copy immediately between panels, you could just hop upstairs to our second floor and get a copy from the library. Two quick logistical things to mention. Today we will be serving lunch to you right outside, but please, we urge you to get your food and return to your seats quickly, because we'll have the privilege of hearing 6 Ohio State colleagues from across campus give these very brief talks about their data-related work at Ohio State. And after our last panel today, we'll be having a reception for registrants at the Barrister Club, which is the facility across 11th Avenue. It's just north of the law school next to Panera. Tomorrow, lunch will be on your own, but we're hoping that'll provide an opportunity for people to interact with one another, talk about the issues we've been hearing about, and then, of course, come back after lunch for our last two great panels and a final talk by Michael Batty from London, which will be terrific on the future of cities. I'd like to say, finally, that the interaction that triggered the inspiration for this conference was a September 2012 morning coffee conversation. Here's a prop. There's the coffee with my colleague, Carolyn Wagner, who holds the Ambassador Milton A. and Rosalind Z. Wolf Chair in International Affairs at the John Glenn School of Public Affairs, and who directs the Battelle Center for Science and Technology Policy. Carolyn has had an exceptional career both inside the Academy and beyond its walls, and would like to join me in welcoming you to this wonderful conference. So I want to thank her and turn the podium over to Carolyn Wagner.
I would start by thanking Peter Shen-Hsieh for his leadership, intellectual and logistical, in getting us all here this morning. So thank you so much, Peter, for everything that you've done. Good morning. I'm Caroline Wagner, the director of the Battelle Center for Science and Technology Policy here at Ohio State. I'm relatively new to Ohio State, and I am so thrilled to be able to welcome you. But I don't have too much to add to the welcomes that Peter so generously gave. So let's just, if we could, take a minute to get to know each other. How many people here are not from Ohio State, have joined us from somewhere else besides? Wow, that's a lot of people. Fantastic. Welcome, everybody. How many people here are from Ohio State? Okay, great. So more than half of people are from outside of Ohio State, so a warm welcome to you. How many people? We have a few people who have come from foreign lands. Can I see the hands of people who are? Okay, so Michael Batty is the lone person from foreign lands. Welcome to you, Michael. How many people here are more considering themselves more on the engineering side of big data? Engineering. Okay. How many people are more on the social science side? Okay. And then how many people would say your focus is more professionally and more on the public policy issues? Okay, wow, it's a wonderful combination of people here. Okay, so let's just, one more. How many computer scientists are here this morning? Oh, that's a lot. Well, that's wonderful because we do need your expertise, especially speaking myself as a public policy professional who's very excited about big data, but who is not too schooled on the computer science side. So I'm looking forward to hearing and interacting with all of you. I'm going to tweet today at #BigDataFuture. So if you'd like to follow me or look it up later, please do, Big Data Future. So with that, I would welcome our first panel to join us. Our first panel will be moderated by my colleague, Professor Beth-Ann Schulke-Leach, who is also one of our big data folks at the Public Policy School. I'm looking forward to this wonderful panel. So please join us.
Yeah, but we still got to get to the other presentations. We've got hearts on there as well. So yours is on there as well.
Yeah. But Venus can escape and right from the festival,
Yeah.
right?
I assume that's true. Okay, so good morning. As Caroline said, my name is Beth-Ann Schulke-Leach, and I'm going to start off. The way that we're doing the panels this morning is we'll give each of the speakers 15 minutes to talk, which will take about 45 minutes, and then we will have 30 minutes of questions and answers. So please be thinking about the kinds of questions that you want to ask. We'll have the microphones at the front, and you can come and ask them. So as they're talking, jot down any questions that you have so that we can ask them. I will also have some questions if there isn't stuff forthcoming. So you don't want to get stuck with what I could come up with. So please ask your own if you can. So we'll start with Dr. Betsy Berry. Dr. Berry has a PhD in linguistics, and she's been working in e-discovery in civil litigation for the past decade, and she has worked on some of the biggest product liability cases of that past decade. So I'm going to let her take it away.
I consider myself a forensic linguist, too. I was just explaining this. I probably should have thought about this earlier, but I do large-scale forensic linguistics. And I'm going to read, because if I go off script, there's no way I'm going to stick to 15 minutes. So although we're talking about big data, today I want to start out by shifting the focus of the conversation before it even really begins, from size or quantity to quality, from big data to better data, or even our best data. By now, we're becoming accustomed to the immense qualities of data from all disparate sources, housing information that we want to access. But if we begin talking in terms of the best data, the most qualitatively relevant data sets, with respect to collection, management, and subsequent analysis, we can be assured that we have the best outcomes, the most valid and reliable results, and resultant insights based on our research. And while the discussion of better data certainly needs to happen in the context of data collection and analysis, it also needs to be addressed in the planning stages of research. And when we are cultivating our research questions, when we're defining the parameters of our research objectives, when we're considering what data is even relevant to our research questions, and when we generate hypotheses and methods for testing our hypotheses. So clearly defined research objectives needs to precede the development and implementation of our sampling, our data gathering protocols, our data transformation protocols, our methodologies, and subsequent analysis. In other words, we need to make sure that we're applying the scientific method to big data. So for over a decade, I've been involved in the legal profession, specifically in legal discovery referred to as electronic discovery, e-discovery. It's the area of the law that deals with the exchange of information to opposing counsel. And with respect to my personal area of expertise in e-discovery, information usually refers to text-based data, text-based natural language data. So I work with large collections of unstructured text-based data, conducting research, investigation, and applying principled linguistic methodologies to solve a variety of problems, mostly in the context of civil litigation and compliance-related matters. Within an e-discovery framework, the legal profession has had to deal with a gamut of issues surrounding very large data sets since before the concept of big data became mainstream. In terms of civil procedure in particular, legal policy favors liberal discovery to promote the idea of equal playing fields for all sides. Hence the federal rules of civil procedure, rules that mandate full disclosure. The federal rules of evidence also promotes a liberal policy of inclusion, relying on a broad definition of relevancy to guide the discovery process, as relevancy is a cornerstone of legal discovery. The Federal Rules of Evidence 401 defines relevant evidence as having any tendency to make the existence of facts that are of consequence to the determination of action more probable or less probable than it would be without the evidence. So what does all this mean in terms of the exchange of information in civil procedure? Because of liberal discovery policy, we find ourselves in litigation and compliance matters with potentially prodigious amounts of data, primarily unstructured text-based natural language data that becomes a centerpiece for fact-finding and intelligence gathering, gathered to support or refute a legal narrative associated with a case. There's also a policy that says discovery, while liberal, should not be unduly burdensome. This is where the intersection of quantity and quality becomes very interesting in the legal field, in my opinion. Unduly burdensome includes time and cost as factors to discovery-related decision-making processes. So the quantity of data and the scope often dominate conversations of legal discovery, and have. Just as size and management of big data often dominates conversations of knowledge discovery in other industries, as well as in academic research. In fact, in the big data arena in general, I would argue that conversations of size and management that address identifying and gathering, conversations of size and management overshadow other important data-related conversations that address identifying and gathering the most qualitatively relevant data, the best data for the analytical task at hand. It seems that we're so focused on size that we neglect substantive conversations about quality. So my involvement in the e-discovery process commences after data collection is concluding. When legal teams have their massive collections of unstructured text and they're tasked with finding information central to their cases and the millions upon millions of pages of electronically stored information, or easy as we call it. It's not uncommon for a complex civil litigation suit or compliance matter to generate 2 million documents. A document can be anything from a 10-word email to a 10,000-page training manual. And this is why I assert that the legal field has really been at the fore with coming to terms with big data. And not just any big data, but the worst beast in the room, unstructured text-based natural language data. It comes with its own set of issues at every step of the way, from data collection to transformation to analysis. And as a field that's based on precedent, dealing with a new and growing problem, but a problem that really necessitates innovation as well as outside expertise and consultation, this has been a challenge in the legal profession. So from my perspective, as an individual tasked with developing and implementing methods for tools for fact-finding and investigation in an e-discovery framework, questions of size and management aren't an issue at all. Methods and processes are designed to scale up. Processing power and storage, they're cheap now. So more so than any technical question now that accompanies large data sets, what's become very obvious to me over the past decade is that produced collections often aren't necessarily a very robust data set for the investigative task at hand. The strength of your case depends on the quality of your data, not the size of your data, not how much you have. It doesn't matter how clever your methods and analyses are. It doesn't matter how great your tool set is. If you have a subpar data set, then nothing else matters. Garbage in, garbage out, as we always say. So in the legal profession, relevancy, which is the guiding theoretical principle of evidence gathering, it doesn't easily intersect with practical methods of identification and data collection. This is a hard nut to crack. Given the nature of the data and the disparate sources in which the data is housed, it makes it even more complex. Relevant data also means something different in every single case. It's not a static concept. It's a dynamic concept, and it evolves as your case evolves, even adding another complex layer to this already interesting issue. So the practical issues intersecting quality, which translates to relevant data, with quantity, it's been overwhelming. However, I believe that now we're at a juncture when we have lots of experience dealing with size and scope, where we can now turn our attention to better data gathering methods without hand-wringing over the fact that there's going to be a lot of data. There's going to be a lot of data. This is simply an artifact of doing business in today's computer-mediated world. Size and management shouldn't be viewed as burdensome. They just come with the territory. And now I think we need to really focus on relevant data and qualitatively valuable data. If we can establish what this means in terms of our research objectives, if we can devise data gathering protocols that best serve our research objectives, then we're going to be moving in the right direction. So a robust data set is the key to a robust analysis. It's difficult, again, to translate relevancy into concrete, definable information that identifies a document or as an email or phrase in an email, a three-word phrase in an email, as potential evidence. But regardless, the legal profession has very high standards when it comes to potential evidence. And by default, the data is the potential evidence. So in many respects, just the research community at large can take cues from legal. The idea of relevancy, the theory of relevancy, is a very good standard to emulate. We have to have a commitment to gathering relevant data. This necessarily entails that we focus on our research questions and our objectives, which in turn makes us contemplate our methodologies, both in data gathering methods and methods of our analysis. In other words, we're adhering to the scientific method when we use this framework. And if we adhere to the scientific method, then we can determine, we're obligated to determine what constitutes a relevant or appropriate data set. And there's an underlying assumption that filters into much of the discussion surrounding big data, that just because there's a lot of data out there, that means that you can answer any question reliably. And to be sure, a lot of data lowers your margin of error, but it doesn't matter if you have a biased data set or just a data set that's not appropriate to your research and your research methodologies. We should be asking ourselves, is this data set appropriate for our methods? Are our methods appropriate for testing our hypotheses or answering our research questions or objectives? And in many instances, it seems that conversations surrounding big data analytics in the legal profession run a little bit contrary to the scientific method. And well, in lots of contexts, actually. We usually start with big data. We have all this data, and we have some cool method or tool that we want to use. And we start trying, we don't start with really clear research objectives. So we just want to use this data set, we want to use this tool, and it's going to give us results, to be sure. But you're not going to be able to validate those results. Your ability to limit those, to interpret those results may be severely limited if you don't have a clear understanding. So I can offer you an example in the legal profession. It involves predictive coding. Predictive coding is gaining steam in the legal profession, and it's a great automated way of categorizing documents. And it entails creating a training set of documents that represent some meaningful category. The training set is used to create a mathematical model of the target category, which in turn is run across a universe of documentation, returning a set of documents that fits the model and hence the category that the model represents. Again, it's purely mathematical rather than linguistic or rule-based. And training set selection is obviously the most significant event that the user contributes in terms of overall outcome. But it can be undefined in this process. So as a method of categorization, it works well. If you already have a document collection, it's great. But now the legal community is using it to identify and collect relevant information. And so the question is predictive coding or predictive modeling the best method for this task? Can we reliably take a methodology that's fitting in one context and apply it in another? And the answer is not necessarily. Given the wide variety of potential relevant material in a typical case, everything from emails to expense reports to memos, everything, if you have a very narrow definition of what constitutes relevant material in your case, then you're good. But that's usually not the case. You usually have a very broad definition of relevancy. And if you use a technique like this, you can be relatively comfortable that if you're going to come up with a model that is expressed by your training category, that your return is going to maybe be relevant. However, what you critically cannot control for is what's left behind. It may not be relevant. It may, in fact, be very relevant to your case. However, you're going to get results, you're going to look at the results, and you're going to think they're great. But what are you doing to validate the things that were left behind? Because I can guarantee you that there is relevant material and lots of it in the things that are left behind if you use a predictive model for gathering relevancy data. Again, it's a perfectly great method, but it's a method that has that was turned to because of the questions of size and management that are dominating the questions of data gathering. It's not only size and management, but it's cost. but it's a method that impacts data quality in profound ways. So if you are just addressing size and management and you're trying to control for that, then you are missing an opportunity to collect qualitatively, the best data set. And this is a good example of that. So if we approach data identification and collection using the scientific framework, then we're obligated to focus on the quality of our data. We don't even talk about size and management. It doesn't matter. We have sampling protocols to come up with that and deal with that. So I know that I'm running out of time, so I'm going to give you my conclusion. So the value of having access to an abundance of qualitatively rich information is that it enables us to ask and answer research questions like we've never done before. However, big data analytics, both broadly and narrowly defined, is a tool that can be used appropriately or inappropriately, as it were, like any other tool. If you don't spend time and consideration cultivating your research questions and outlining your parameters, your objectives, if you don't understand how your data relates to your research question, and finally, if you don't understand your methodologies, then you're going to end up with results that you cannot appropriately interpret. After all, understanding, you can't automate understanding, and bigger does not necessarily mean better.
Cool. That was a great start. So now Harv Miller is our next speaker, and he is the Bob and Mary Reusche, I apologize, chair in GIS. This is why I didn't go into linguistics or languages. And a professor at Geography at OSU, and he specializes in spatial analysis and GIS techniques, geographic information science techniques. By the way, all of the speakers have their profiles in this little book here, and so we're not going to go through them in detail, but you're welcome to look up and get more details, because they certainly deserve more than just the few minutes that we give each one to introduce them. So, welcome.
Thank you very much. Happy to be here. Thanks for the invitation and share some thoughts with you. I want to talk about the new space-time data science and why it's relevant and important for an increasingly dynamic world. What's happening now in the world is that real-world space-time dynamics are becoming more complex. At the same time, the capabilities for collecting space-time data are increasing. So I really have a simple message in this talk, which is a challenge. Can we discover and deliver appropriate spatial temporal knowledge quickly enough to make a difference in the world? Now, why is the world speeding up? Well, one reason, and the big reason, is space-adjusting technologies. These are things such as transportation and information and communication technologies. And these things basically change the nature of space with respect to the time, cost, and effort to overcome space. And because of that, they redistribute human activities in space and time. So I have some examples up here, the train, automobile, the real revolution. I think this is the latest one there. The telegraph, the first time we can move a message faster than a body could take it. The internet, commercial aviation, and the mobile phone. In fact, right here I have, that is Martin Cooper, the father of the mobile phone, holding in his left hand the 1973 original mobile phone. It only had a 20-minute battery life, but it weighed 2.5 pounds, so it didn't make a difference because you couldn't hold it up that long. Come a long way, haven't we? Now, space-adjusting technologies in the contemporary world have led to space-time convergence. And space-time convergence is it decreases in apparent distance over time with respect to due to mobility and communication technologies. And the implications of the world shrinking is that we have increasing mobility at all geographic scales, from local to global, and our activity organization has become much more complex. This is a cartogram behind me. It's a kind of a famous one from an intro human geography textbook showing the world shrinking because of transportation technologies from from sailing and horses to steam engines to propeller aircraft to finally jet aircraft. And this is the relative size of the world shows basically the effective distance with respect to time, the fact that we can trade time and get more space with these increasing transportation technologies. But in addition to the world shrinking, the world's also shriveling and fragmenting. Shriveling means that the absolute transportation costs in the world have decreased over the last 2 centuries, but the relative differences are increasing. So some people can drive a car, some people rely upon public transit, some people have to suffer with the commercial aviation industry, some people have private jets or have timeshares in jets. Some people are stuck in traffic in LA. Other people, studio executives, are getting around by helicopter. So even though we've been able to shrink the world with these mobility technologies, the differential has increased. The world's also fragmented, especially in the last 20 years or so. Activities are disconnecting from specific places and times. For example, I'm a professor, so as long as I'm not in a meeting or at a conference or I'm lecturing, I can work anywhere there's an internet connection. I like to work at a cafe about a 5-minute walk from my condo here in Columbus. Great place to work, great place to think. Now, for me, that's work. That place is work. The barista who made my latte, she can't work from home. She has to be there. So it's not true for all professions. If you work in knowledge and information, basically you can work anywhere you have an internet connection. But for all of us, you can shop anywhere as long as you have the internet. You can recreate. You can socialize. They're not specific privileged locations and times for these activities. They're much more spread out over space and time. Now, because of that, the world is speeding up. We're seeing higher urban metabolism, a hyper-coordinated city with increasing dynamics and more intensive resource use. And this is a big contrast with how we manage cities. We manage cities still using a place-based perspective, using incremental changes, assuming incremental changes, assuming if we make a small change in a city, there'll be a proportionally small outcome. And also we tend to think linear. We tend to think, as I said, that small changes lead to small outcomes, when sometimes small changes can lead to big outcomes in cities. This is also creating increasing shearing forces, the mismatch between dynamics of different systems. Human systems are speeding up, but physical and biological systems remain slower. A lot of the environmental problems we see in the world are because of this mismatch between what humans are doing to the world and the ability of the environment to respond. But we do have some opportunities here. The world's sped up, it's shrinking, shriveling, getting more complicated, but our ability to collect data on these dynamics have increased substantially. We have things like remote sensing, taking images from airborne platforms or space. I have behind me here a LiDAR image, which is laser detecting. You can basically fly over a neighborhood or a city with an airplane with a laser and get a 3D footprint of the city at the centimeter scale. I've seen images where birds fly under the laser and you get actually an image of the bird that's that accurate. Geosensor networks, putting sensors into geographic space that know their location and can report different things about the environment. Location-aware technologies such as the global positioning system and cell phones. And something we heard about last night, georeferenced social media. A lot of check-ins and Facebook updates and Twitters are in fact georeferenced. We have new science and tools for exploring massive spatial temporal data, and also science and tools for simulating systems at the level of an individual. Even when we don't have the data, we can actually simulate these complex systems. We can now simulate the behavior of a city at the level of the individual in near real time. It's a real revolution in how we approach cities and transportation and social sciences in general. This is some of the examples and the data we can collect. This is a study I'm involved in, which is at my previous university, University of Utah. We are looking at the impact of light rail construction on people's active transportation behavior. So this is just one of our data sets. It is GPS data for 900 plus people over 4 days. It's about 50 million GPS points, of 30,000 trips. The red there is basically the GPS cloud. That's not the street network. The street network is actually gray and in the background. And you could see that's a lot of data. It's interesting. We have a grid network here, but it looks very organic, like a tree. How people use urban space. So we're going to have this data before and after the light rail construction. Plus, we have block-level walkability measures, about 170 attributes per block in our study area. We sent the Army of Research Assistants out to collect that data. All of it's georeferenced. We have transit schedules, transit usage, traffic counts, parcel-level land use data, census data, weather data. We have oodles of data about this environment, and it's an unprecedented opportunity to understand how people use the built environment, how they respond to changes in the built environment with respect to their behavior. We're also moving towards sense cities, where we have billions of sensors carried by people, such as cell phones, in vehicles, embedded in infrastructure. We have wireless communication. These sensors can talk to each other. And social media, user-generated content, and also something we call in GIS, volunteer geographic information. People checking in about what's going on in their environment, and also people voluntarily mapping environments. You may have heard of OpenStreetMap. That's a totally volunteered, bottom-up effort to map the world just based upon people with their cell phones. So this is an animation here. I just wanted to show it's not mine. It's from Joe Wood in City University of London. And what it is the first 5 million bicycle journeys in the London bike share. Now I'll just start the animation and talk about it a little bit. So this is basically the same data set shown over and over again. And this is 5 million bike trips in London. And what's happening here is that Joe is adjusting the animation. He's basically adjusting the parameters, such as how long the tails are of the moving objects and how bright they are to try to pull out the patterns in the data. So you can see at first it's kind of a mess, but as he adjusts the parameters and highlights more predominant trips, you could see that patterns are starting to emerge in this data set. It looks very simple, like a very simple visualization, but there's a lot of thought that goes into this. And you can see now that he's emphasizing the tails and emphasizing dominant flows here. You could see now the pattern of origin-destination flows among bikes. Bike shares in London is really starting to pop out. And towards the end here, you'll see that, again, with further adjustments and filtering out the noise and concentrating on the signal, the major flows, we can really see, at least based on bike geography, we can see the spatial pattern of London, London as a city, its structure. Looks like there's a real disconnect between the East End and West End. Would you agree with that, Mike?
That's the city, basically.
Okay.
King's Cross at the top, and we also do mainline stations, and that's Hyde Park on the left.
Right.
But it is interesting. You can see the geography.
Yeah. Thank God Mike was here. Very good. Okay. So this is the kind of things that we can collect now. We can sense cities and get these dynamics in real time or near real time. So what's the big deal about all this? Well, volume is a big deal. Volume, we're saying big data is data that overwhelms our capabilities to analyze it. Yeah, that's true, but it's an old story. I mean, the U.S. Census going back to the 1890s, the estimate was that it would basically take longer to count the census than it would for over 10 years. That's where IBM actually came from, business machines invented to tabulate the 1890 census. Also in geography, when we first had Landsat, which is our first major satellite remote sensing system, in 1970, we were immediately overwhelmed by the amount of data we were downloading from orbit. But I think is really more interesting is the variety of data, structured and unstructured data, and this can all be integrated based upon geographic location. The ubiquity, the fact that we can collect data naturalistically, not with the controlled experiments, but monitor events as they occur, both mundane and unplanned events. And then if we see something unusual, we can reverse engineer the dynamics to see what's happening. And one thing I want to concentrate in my remaining few minutes is the speed of the data. We have increasing speed of data flows, and the bottleneck increasingly is going from data to decision. Now, there's a technical dimension of going from data to decision. One is detecting patterns quickly. And there's a lot of issues involved in this. One is rapid space-time data fusion, trying to integrate real-time data. There's both syntactical issues, is the data in the same format, but also semantic issues, which are more difficult. What is a neighborhood? What is a city? What's a mountain? These things vary by culture, by language, by region. So trying to integrate data semantically is often very challenging. In-stream data processing, the ability to act upon data before we actually store it, and also spatial temporal change detection. What differences make a difference? Perhaps even more interesting for me as a social scientist is the conceptual dimension. What are the decisions that we can make quickly? Now, traditionally, what we do in social science and in planning is we forecast and constrain. We come up with a model, a long-term model, and then we expect people to behave that way. But increasingly, we're moving towards at least supplementing that with a measure and nudge paradigm, where we try to predict the present, try to describe the present with as much detail as possible, and then seek immediate local actions to nudge these space-time dynamical systems into good outcomes. So one of the things we're thinking about is how do we come up with spatial temporal indicators, simple measures that indicate difficult to detect spatial patterns, but especially can lead to actionable outcomes in the sense of this helps you make a decision, because that's what this is all about, decision support. So conclusion is that spatial temporal dynamics in the world are increasing. We have a shrinking, shriveling, and fragmenting world. At the same time, the capabilities for collecting spatial temporal data are improving. We have bigger volumes of data at wider spectrums, at faster speeds all the time. And our bottleneck is the time from data to decision. So can we discover and deliver appropriate spatial temporal knowledge quickly enough to make a difference in this speedy and complex world. Thank you.
So next, our third speaker is Angela Shen-Hsieh. Shen-Hsieh. Thank you.
Shen-Hsieh.
Shen-Hsieh. And she is the Chief of Product Design for IBM Business Analytics, and she's the driving force behind the Watson Analytics data discovery products. She has founded several companies, and she holds 6 patents, so I'm really looking forward to hearing her.
I don't know which one of these is yours.
It'll be the PowerPoint one.
Well, there's several of the PowerPoints. Oh, it is, okay. That's it? Oh, yeah, there it is.
So I work for IBM and I design software, and the kind of software that we make in business analytics, what it's trying to do is fundamentally make data more meaningful for human consumption. And so I work in this area that I refer to as the last 18 inches. So now that we can get data to your screen, how do you get it that last 18 inches from the screen into your brain? I am really interested in languages, visual languages, experiential languages, languages of interaction that bridge that last 18 inches. So imprecision, really. The reason why I'm interested in imprecision here is because a lot of the stuff that we work with in business analytics, like data visualization, they're really fundamentally about things like abstraction and metaphor and narrative. And these things are inherently imprecise. And so is human decision making. So I'll reiterate the point that all of this data and all the trouble that we go to capture it and store it and analyze it and get it to the glass, it's all about decision making. And human analysis, it's not just about getting the number, querying and getting a set of numbers or, a block of text and, great, that's it, that's the decision. The decisions of business, what markets to go into, who to hire, where to invest. I mean, those are soft decisions that involve a lot more than just an answer that we can get out of a computer. So in business, the important and high value decisions are really people decisions. So again, the interest in getting it that last 18 inches. So decision-making processes around data, they're not exact. Something that I find myself saying a lot is that statistical relevance is not necessarily relevant for my business. It doesn't necessarily equate to business relevance or decision-making relevance. I don't think that, say, Apple had, statistical confirmation that, a 10-inch phone was going to change the technology landscape. They have their intuition and their gut feel and their expertise and their experience with the patterns in their business and in their markets and with their customers. How do we provide ways to connect data into all of that stuff in the minds and the guts of decision makers? So I'm going to talk about a couple of quick concepts, and then I'll show you something that I'm working on. So in a lot of ways, context is actually more important than the actual content. Sorry, I have to crane a little bit. So you see a couple of bars here. I mean, the length of the bars could be sales, could be people, could be, average temperature. And we get some idea of the relativeness of, the Midwest is less than the Pacific is less than the Southwest. But how is this, actionable? So what was I expecting? So now we're starting to layer things on, and how we articulate and render this kind of data emphasizes certain kinds of things in the human thought process. So here, what's bigger, what's more than the expectation. Here, highlighting, what's less. I mean, you can imagine it's different for different kinds of, people or groups or in different kinds of situations. I'm flipping it over and seeing it over time. At the bottom, I'm emphasizing the above or below that goal. Now I'm seeing a portfolio of like things and understanding how they change and add up over time. So the accuracy of the number is not necessarily as important as the context in terms of decision making. And then metaphor. So to understand things, our minds need metaphors. And a lot of people believe that it's really akin to thinking. So metaphor is akin to thinking. So we understand things in terms of other things. And so metaphor is naturally not precise. It's not an accurate rendition. This is actually a horseless carriage. So for a long time, this was known as a horseless carriage. Why? Because everybody knew what carriages were. They had been around for a long time, but no one knew what a car was or what it could be. So a carriage without a horse. There's actually a lot of really interesting stuff about the universal metaphors, primary metaphors, which we all understand from the time that we're children. And some of these I really like. Bad is stinky. Help is support. Change is motion. Knowing is seeing. Oh, I see. Understanding is grasping. Ah, I get it. And this applies to visualization and visual metaphors. So important is big. And things that are clustered together, they imply a similarity. Org charts. The organization represents some kind of, the physical structure represents some kind of an organizational principle. Control is up. So if you flip over an org chart, it doesn't make any sense to people. So a quick story. So this is a visualization many years ago, 10, 12 years ago. I worked with a lot of pharma companies, and this is back when getting data into a visualization like this was really heavy lifting. I mean, 6 months to a year kind of projects, building everything by hand. So this company, when they first saw the data, this is a drug portfolio, so each one of these bubbles represents something in drug development. Their reaction was shock and awe. And this is a company that they know their data. I mean, they work with it every day. They know it inside and out. but they had never seen it this way, and it changed the way they understood it. What also happened was that when the data was first loaded, there was one really big bubble and then lots of small ones. You know why that is? Bad data. They had a couple of extra zeros. And it's something that they didn't spot in the data, but when they saw it in context, it was immediately apparent. Metaphor, it is akin to thinking, and it's inherently imprecise. So I'm going to show you a quick demo of something I've been working on. I have to just put up the obligatory disclaimer. You don't have to read it. I don't exactly know what's in it, but I will say that I've done it. Okay. So this is let's see if I can get this.
Laser?
You know what, I need to let's connect. How do you, sorry, it's been a long time since I've been on a PC. No, it actually, if you click on that, it should start a movie.
This one?
Just anywhere, just click on, should start a movie. Okay. Uh-oh, that doesn't look good. It worked on my Mac, I swear. Can you go into that file and see if that works?
This one? Yeah.
Yeah.
That should work.
Okay.
There we go.
Okay, great.
Whoops. Well, that's it there.
Okay, so this is something I've been working on. It's a data discovery product called Watson Analytics, codename NEO. And what we're trying to do is create this way of having a conversation with data. So you saw a search box, and you can type in a natural language question. The system finds the data. Then it does a statistical analysis, and it does a semantic analysis of what you asked for, and it produces a visualization. Now, the visualization, it tries to answer the question, but this answer is not the end point. This answer is actually the starting point for a human analysis. So we're trying to find a way to engage all that good stuff that we've got in our brains, all our knowledge and experience and intuition and gut feel. And so this conversation is enabled through interactions with the data. So we can we can facilitate this this sort of Q&A and this kind of train of thought that's led by the data. So I see something that's big, I see something that's dark, and how do I ask the next logical question? Ultimately, we're trying to find that visual language, that language of interaction for analyzing data and hopefully helping people to make better decisions. That's it.
Thank you. So if anybody has any questions, they can come up to the microphone. I'm going to start by asking if the panelists have any questions for each other to start with, because otherwise I'll start with my questions. So the first question I wanted to know, starting with Angela, is what does, so we hear the term big data a lot. We hear the term data-driven decisions. And do you have a definition or what you kind of think that means in terms of how we use information? And when we hear the same thing with business intelligence and business analytics,
Right.
we kind of hear these buzzwords,
Right.
but we don't necessarily really understand what they mean.
Yes, I think there's a broad range of understanding of what they mean, and I'm from the commercial side, so yes, they're buzzwords that everybody uses. You can go to everybody's websites and you'll hear about better decisions and decision support, things like that. Again, to me, I think that yes, there are decisions that are inherent that a computer can make. As far as kind of what I do and what I'm interested in, you don't need visualization for a computer-made decision. If it's buy, sell, you don't need that. And so, data-driven is not necessarily a decision that's made by data. It's understood in the context of data.
So it's using data to make better decisions. Is that?
It's using data to. Well, there's a lot about sort of decision making. There's this term I like, which is that there's a comfort zone of decision making. So everybody has in their head this sort of comfort zone. It's fuzzy. It's like a cloud, and you're pulling data points in, and there's some point at which you feel comfortable to pull the trigger. But that part of what you're pulling in is different kinds of data and information to make up that sort of comfort zone, to fill out that comfort zone.
Mike Nelson with Microsoft. In the middle of last year, about July, I realized that we had hit the peak of the hype curve for big data. And I realized that because David Brooks wrote 2 very skeptical columns about big data. We'll know we've reached the peak when Oprah has a session on big data. But Brooks made an interesting point. He decried dataism, which he described as what happens when CEOs start making decisions solely based on the data. People come in and say, well, the data tells us we have to do this. And they put aside their judgment, they put aside their experience, and they start making decisions that they can blame on the data, and often make really bad decisions. The audience here is a really diverse one. We have a lot of lawyers and computer scientists and policy people like me. I don't know how many business majors we have. In many companies, it's the people trained as business majors who are actually making decisions about how to use big data. And some of them, the CEO with the business degree is told by the lawyer, get rid of your data, we don't want it to be discoverable. In other cases, they're being told by the research community that there's magic things we can do, and they spend a lot of money on big data. In other cases, they're doing what David Brooks describes, which is making bad decisions based on bad data. So my challenge to each of the panelists, if you were designing an updated MBA curriculum, what's the one course that you would want every MBA to take on big data?
Good question.
I'm not a business school professor, but I can comment on some of that. I think what you're saying is absolutely correct, that we have to avoid leading ourselves into a data dictatorship where we let data make decisions, not people. It's like I said, it's decision support. There was actually a very interesting article in Science this week about Google Flu trends, which first worked well and then didn't work well. And the article is like a forensic analysis of what exactly went wrong, and some of it was data hubris.
That's a great phrase.
Yeah, basically, some of the factors, the variables they used in Google Flu trends were things that predicted winter, didn't predict flu. They were just spurious correlations. People weren't thinking about this. And also things like changing the algorithm, the query algorithms at Google, so changing the kind of technology as the model went on. So I guess I would say 2 things in terms of what I'd like to see in a coursework, not just in MBA, but even like in my area, Geographic Information Science. One thing is ways to understand and communicate uncertainty. I think that's critically important. We communicate the message from data, but not the uncertainty around that. Another one would be data ethics. I think that's a course actually we're considering for our GIS curriculum in our department. What are the ethics of using this data? What are the privacy implications? What, when we make decisions, what's involved? We have to basically think about the implications of it. So that's two things I would like to see, at least topics covered in any curriculum dealing with data.
I've got an answer. I'd like to see methods. I mean, the more you understand sort of like behind the curtain, the more you can kind of, data isn't this, magic thing that somebody's pushing at you. If you have an understanding of it, it's not so scary. And then you don't have to rely on, you don't feel compelled to, you can really evaluate data if you get in there and roll your sleeves up and learn how to measure things. If you really understand methodology and research, if you actually if you take a course where you actually have to use data, like, gather some data, you have to contemplate, theoretical things and concrete things together. I feel like that this is something, that we had, I had to do this and, they made us do it in linguistics, but it's startling because, here's the thing, in language, and especially in my field, and of course, I'm the center of my universe, so, everyone has an intuition about language. Everyone has an intuition about data. And you start, when you're faced with something that runs counter to your intuition, you get confused. And I think that this is a point that you were making, that like there's a comfort zone. And people need to get there frequently and understand how to parse all of this information. And if the really only way you can do that, and I hate to say it, you need to measure stuff. You need to be dropped into a situation where you have to actually drive the bus a little bit. It's going to be uncomfortable. You're not going to understand it, but it's going to force you to sort of develop a relationship with data that doesn't really exist. There's a gap right there, in my opinion. I think that's why we have this, you're calling it data hubris. It's sort of like, I think that I don't think my 9-year-old daughter is going to have that at all, but the people right now, we have it. And, I would like to see people actually be forced to measure something, to get into a business school and do some data analytics and think about what that even means in terms of their, relevant to their, what they're interested in. That's what I would like to see.
Yeah, I actually find that kind of surprising that particularly in business, that you find that people make decisions just based on data and not sort of following their intuition.
It's a lot safer. If you can blame the model, you can't get sued as easily.
Yeah, but you know what? You have to have. I actually find that people will because they don't have enough of that data to fill out that comfort zone. They either don't make a decision or they're gonna kind of look elsewhere for different kinds of confirmation. I mean, what I find is the challenge is getting. Again, it's not just that number, but how do you trust where that number came from? And so a lot of what we do is try to provide ways that when an executive or a decision maker is presented with some information, they have ways to query the model. I mean, if you don't, I mean, if you aren't able to kind of play with it and understand the dynamics, understand the tipping points, if I move this a little bit, 3%, actually this thing changes by 30%, and if it doesn't respond in the way that you think, then in my experience, managers throw out the whole thing. I mean, I agree. Like I run a design department, and what I make our people do is find some data and actually have to go through that process. Go through, like, people use it like cell phone data. They take their cell phone plan and they try to figure out, like, well, why would you look at this data? What is the purpose? What are you trying to do? Am I trying to save money by figuring out what the better plan is? Am I trying to understand whether when I should cut down on making calls, things like that, and to take them through that sort of thought process through a set of data.
Thank you.
So I think my question in a lot of ways is a follow-up to Mike's and to some of your comments. And that I should start by saying one of my favorite academic jokes comes to me from a behavioral scientist who said, "Now that I know about confirmation bias, I see it everywhere." And I guess, and my question is, how does the turn to data sort of intersect with what we know about decision-making, cognitive biases that distort decision-making? I worry very much. I mean, I understand, that your presentations were terrific, but it's very easy to imagine how visualizations could be designed or searches for quality data could be pursued or not, depending upon, now I'm getting the thing that I expected. My favorite example of this is, I have to say, the U.S. News and World Report law school rankings. A bunch of data points are assembled which are arguably unsound. I mean, the reputational rankings. They are weighted. It's not clear that they have any relevance to the quality of education. And then they're weighted to produce a result. The weights are utterly arbitrary, except that they had to be chosen so that the top schools would be Harvard and Yale. If the top schools turned out to be, Notre Dame and South Florida, then the scheme would have been rejected no matter what the data were. Now, I'm happy as a Yale grad for Yale always to be number one. But if that's what, data modeling means, we're going to come up with the model. It's going to start with verifying the assumption we brought to the model in the first place. That doesn't seem like an aid to decision making. Question mark.
Well, I mean, there's cautionary tales just in our popular media. I mean, the world's flooded with media, but now people can cherry pick what they want to listen to. Some people listen to MSNBC, other people listen to Fox News, and they get totally different views of the world. It's like a confirmation bias. I can't speak much about the cognitive aspects of it, but I will say that there are principles in database decision making that have existed for a long time that can help us get a handle around this. So there's a long existing area called multi-criteria analysis, where if you have a bunch of attributes and you have to weight them to come up with an overall indicator, what's the effect of the weights? And there are ways of eliciting that from decision makers. There's also ways of playing with the weights to see how the results change. And this is stuff that's existed for a good 30, 40 years in the literature, and I think we need to, we're kind of rushing into big data, but not thinking about some of these principles that exist that can really inform how we approach big data.
Well, I would say that, where'd Peter go? I want to look at you. That, if you get to a place where you're comfortable, I mean, immediately I go to those you need to be able to decipher exactly all of the things that you laid out, okay? So that they weighted it. How did they weight it? Well, they just had some arbitrary weighting, and just the ability to have that conversation is huge. A lot of people don't. They want to be, it's much more comfortable to be told, here are the top two, here's the, and everything else. That you're right. That is what we expect. But if you just have a few critical thinking skills when it comes to data, and just not make this assumption that it's all good, that the data was it was all they used a scientific method. It was it's all reliable and valid results, defensible results. I think that just those things. I mean, even my daughter does that now. She'll see some information, a ranking or something, and she'll question the input. Just questioning the input and how you got that data. That alone can make. I mean, it's just another piece of information that allows you to sort of assess your world. I think that I think that we're getting past the point of it's that we just. Oh, great, another ranking. That's somebody crunched some numbers, and now I don't have to think about that anymore. That somebody's done the work for me. Well, you know what? Big data doesn't make for less work. It makes for more work on your part. You need to actually get in there and roll your sleeves up and get comfortable with it. It's not, there's no answer at the end of the, it's just sort of the beginning, actually. I don't know if that makes sense. I'm rambling.
Yeah, I agree. It's again, it's decision support. It's not decision making, and you have to think of it in that context. I mean, but actually, in my world, we actually want to enable a point of view in the kinds of visualizations that we allow our customers to be able to make, and that's because the business has a point of view. So the business is trying to align the people around a certain strategy, a certain direction, and the way that they want people to analyze data, the way they look at the information is key to that alignment around the organizational decision making. So we actually want to be able to put that a certain amount of bias or perspective, point of view into the views of data.
Well, I was glad you brought up the scientific method, Betsy, and I agree that studying data is great for coming up with hypotheses, and predictive and mathematical models are great for testing your results. But what fraction or how much emphasis can you put on quantitative analysis and mathematical modeling in the analysis stage of it?
It depends on what your task at hand is. Like I said, like predictive numeric coding is awesome once you have a produced set, once your universe is defined. You can, it's great. It requires an interaction with the data. You have to come up with a training set of documents in order for the machine to learn to create a model. And that's good. It requires some, but that's one task. Like, in my world, in the legal world, this is very interesting because I see a contrast because you have there's some stark differences here. A lot of times, really what you're doing is you're using a hybrid methodology. You're using statistics to help you winnow down a collection of data so then you can make a qualitative decision. We like to say, in Illocution, my company, starts with a human, heavy lifting computer, ends with a human. So it's not an either-or situation. It's that you're going to have to use some quantitative analysis. When you're dealing with massive quantities of data, you're going to have to actually do some statistics, even to come up with a simple sampling protocol. You're going to have to actually have an understanding. So, but then you might get your data and do a purely qualitative sort of approach. So I wouldn't say. It just depends on the task at hand. But unfortunately, you need to be aware of. You need to know how to know the difference. If I had a dime for every time I saw a linguist doing some really terrible statistics, I go to the biggest conferences and I'm shrinking. I'm like, no, you didn't. But it's because it's that you need to understand. You really just need to know when it's appropriate, when it's not appropriate. Sometimes predictive coding, modeling is great. Sometimes it's not appropriate at all. So I hate to just say it depends, but it depends.
Yes.
If I can add to that, I don't view big data as a substitute for the scientific method or for modeling and statistics. To me, where big data has its value is not in hypothesis testing, it's in hypothesis generation.
Right. Exactly.
We have data, we see new things we never saw before, then the scientific work begins. We have to validate those patterns.
That's
but
true.
we can't just look at those patterns and say that's the truth.
And that's actually great because now I love that. That's a great point. Is this dynamic sort of process of decision making? No place is that better than legal. Things evolve and it's dynamic. It's not a static sort of thing. I completely agree with that.
To me, big data is like scientific instrumentation. It's like getting a telescope or a microscope to look for new things and then starting the scientific process.
Okay, I guess as a follow-up question, so if you did the modeling, you got the perfect diagnostics, your results make sense in the real world, would you ever feel comfortable putting more than a third of your overall decision or half of your overall decision, basing it strictly off the statistics that were generated? So, or how much emphasis, given you got the perfect results, how much emphasis would you actually play?
There's no perfect result.
Yeah.
There's only good statistical fitting.
Right.
Who knows for everything you measure, there's a million things you didn't measure. So you may have a perfect fitting model, but it's only based on what you measured. There's other things in the world that we can't measure or difficult to measure. There's also values. Like when we're making decisions about the future of our city, we shouldn't base it upon any model. We have to use that as as a stream of scientific evidence, then think about, well, what are our values? What are our preferences? What do we want? So again, I want to emphasize all of us. I think we all agree it's decision support. We shouldn't let models or data make decisions for us.
The other thing I hear, which I want Angela to follow up on, is it depends on the context in which you're trying to make a decision, because as Angela was, which really interesting to me, is the idea that businesses often want their data they're not using it the way an academic would use data. They have a goal and they have a process, and they don't want data to just be out there on its own. They want to have some structure around it that allows decisions to be made in certain ways, if that's what I hear. So that how you use that data and what you would do would be different depending on the context in which you, and what questions and answers you're particularly looking to do. So
Yeah, there's one more, there's a concept these guys, the Strategic Decisions Group, have about ready, aim, fire, and ready, fire, aim. So decisions, so a lot of it depends on the length of the feedback loop, because to your point, there's this, you put something out there, and then you get feedback from it, and then you iterate, you make an adjustment. That's a whole different kinds of decision life cycle than something where you're placing your bet and you're not going to get feedback, you won't be able to change it for a long time. Those are different kinds of decision processes.
I think we'll go on to the next question.
As we were just reminded, Angela Shen-Hsieh made the statement that context trumps content. And with that in mind, I was going to ask Betsy Berry a question about electronic discovery. The question is, if, at least in a journalistic expression of these litigations, it seems as though half of them turn on specific facts that were uncovered, and half of them, at least about the emails, turn on attitudes that people have. Is there a different protocol for each of these relevancies, or can you dig it all out with the same protocol?
Well, again, relevancy when you go to collect your relevant data in the legal framework, you don't even know how that is concretely manifest in language data. It evolves, and I mean, the fact is that the model just needs the framework that you're operating in just needs to take that into account. That you're going to have a whole different, in 6 months' time, you're going to have a very different idea of what sorts of people are important. You're going to have context is going to be filled out. You're going to know what time frames are important. You're going to know who are the important people. In the context, I can give you just, anecdotally, if a very sort of lower rank person says something, sort of distasteful after the fact, or, like in response to something, that's very different than the CEO of a company, kind of expressing a sort of distasteful opinion, really at a very early date before like a product recall has been issued, or do you know what I mean? Context is something that you learn as you go, and the framework is, and it is hard in the legal fields to actually create an automated method of going back and making sure that you can troll the universe of data and get the data set that's going to give you the fact building tools that you need to substantiate or refute a narrative. It's very difficult. So I don't even know what your question was, because as soon as you said something, so is that kind of?
Well, let me rephrase.
Yes. Okay.
Is context trumps content what you were talking about when you were talking?
It doesn't. It informs it. I love what you were saying. That
I'm just being provocative to see if you're
well,
awake
this
early in the morning.
I think about this differently. I don't think that we need metaphors. I think that humans want categories. We want to know how to file something. And the broader the category, it's hard. But what crucially starts to happen, which creates context, is we start overlapping categories.
Yep.
We get more specific. Humans
Bucketing.
are
We call it bucketing.
Yes, we're fantastic at doing that. So, you know, I think that, and that's what, it's not, context doesn't exist in a vacuum, content doesn't. I mean, you know, if I tweet, the markets are going to hell, who cares? But if President Obama tweeted that, we would have a problem, you know? I mean, it's the interaction of these things together, right? And so humans, we are so good at doing that. And, you know, we're really great at programming computers to do that as well. It's just that, I don't think that one trumps the other. I think that they inform each other in very, very profound and complex ways. And I really think that, you know, as much as we use a computer to do the heavy lifting, it's the human, you know, it's the decision support. That's exactly what it is. That's what it is in legal, that you, you know, you just need the ability to visualize it, I guess.
I think you were waiting a little bit longer.
Okay.
So
Well, mine's following up on that as a lawyer, but it's more about the culture of law in terms of understanding how science works and how it fits into their work. So, you know, lawyers were among the first professions to adopt digital access to information, and then it just kind of stalled. Computation in legal analysis never happened, doesn't much going on. But then this e-discovery thing comes along, and firms seem like they're investing very heavily in the scientific apparatus to find information. I just wonder if you have sort of any reflections upon the culture of science and how that works with the culture of law.
Not enough time to do that. Absolutely, I do. I think that what we're seeing now is that you're right. That's why I say that, you know, in the legal profession, they were really one of the first professions that had to deal with the exigencies of big data. It's like, we need to take this massive data set and make it not massive, and we need to take it into court, or we need to take it before a judge, or we need to, so, you know, but I think that really the gap comes in is that you have, you know, a field that's based on scholarship and precedent, and you have a very innovative, speed of light kind of commercial technology, e-discovery industry. And I think that there's a gap right here. You know, you need sort of people in the legal field who do this sort of research, and then you need people in the well, I don't even know if it's commercial. You know, you need that sort of, you know, we don't need another e-discovery widget. We don't need another, you know, great piece of technology. We need legal experts and technology people discussing what the objectives in the legal community are, and how can we, I don't want to sell you a sentiment analysis. Oh, no, I do want to sell you a sentiment analysis tool. You know, in the legal profession's like, oh, you know, that's cool. I could see how that's useful. You know, it's this sort of, but it's their willingness, but I think that the problem occurred at just the commercialization, where the research, there was never ever really good body of research to inform these two pockets. And that to me is, I mean, again, that's a conversation that I could have, you know, all day long. But that's where the kind of, the Grand Canyon of, you know, the Gulf comes in, the gap.
Question for Angela. I'm a geographer. I have an interactive mapping company. And what we've discovered with our clients is that people will use the same data, the same person will use the same data differently depending on the device they're using. So if they're looking at a big screen at home or at the office, they will do more planning for some map they're going to travel to. If they're walking down the street with a phone, they'll use the same data differently. Yeah. And the same is true for an iPad, right? Mm-hmm. Has IBM started to evaluate how people might use that data with Google Glass?
With Google Glass, I can't speak for the whole of IBM, the 400,000 people who are, I'm sure somebody is looking at that. But we are very focused on how mobile intersects the various use cases of the various users that we have. And I think the first approach was always, okay, it's big, and then it's, you know, smaller, and then it's smaller. We actually take a mobile-first design approach. So we actually design first for mobile, basically iPad, you know, tablet size. It completely changes the whole approach to what software looks and feels like. I mean, you sit in front of a screen, you start to think about how to do something. You are not thinking about big menus of things. You're not thinking about tools, tool sets, and I think that's important.
Thank you.
I just have one quick question, because we don't have more than about 90 seconds. But one of the questions that seems that all of us sitting up here, I mean, Angela, you have a master's in architecture, and Harvey's a geographer, and Betsy's a linguist. And I just want to get your kind of input on, because there's kind of this emphasis on big data, on computer science and the technologies. And what I want is your perspective of the other skill sets that you bring to analyzing and understanding big data, and also in terms of the need for collaboration and bringing people with different skill sets to the table. You can't, my feeling is you can't possibly have all those skill sets yourself when you're dealing with this. So I just would like you to comment on that. We'll start with Angela, if you want.
Yeah, well, yes, I'm an architect, like a building architect, not a system architect. And as I like to say, architects don't build buildings, we actually make pictures of buildings. So that's actually our deliverable, our competency is graphical representation. But it's for a specific purpose. It's for a specific kind of human analysis. It's to explain or understand a condition of the built environment. And so that sort of same approach of using different kinds of graphical techniques, not perspectives and axonometrics and plans and sections, but other kinds of graphical techniques, the language that I talked about, to be able to do the same thing with data. I mean, we're essentially sort of slicing, cutting data in order to explain it to people and have people able to understand it. So those are the sort of competencies.
Well, I know, I teach geographic information systems here at the university, and I know that I'm not trying to create computer scientists. Most of the students who take my classes are users of software, and they maybe will modify it a bit, but they're not designers of software. What they really need to do is they need to bring technical expertise, and that's not only with computer science, but with some, at some level, and also with analytics, and also critical thinking, but they need to fuse that with domain knowledge. So I want my students to know enough of the computer science of GIS to be able to talk to computer scientists and be able to know what to ask for and know what they're saying when they respond to them. But what they bring is not only that kind of technical orientation, but knowledge about things such as society, cities, transportation, land cover dynamics, things like that computer scientists can offer. So I think collaboration in this area is essential, and I think we need to figure out a way to bring domain experts into this as much as possible.
Well, I'll say, from my perspective, humans use language to communicate. And, so you have to, linguistics, for me, I didn't study anything technical. I'm a language variationist. And I work with a lot of NLP people and computer science, computational linguists. And let me tell you, they're a very different beast than, someone who studies. I mean, the whole reason that, my interaction with language is that one person has a million different ways to say the same thing. And, I would say that, you have to actually have an understanding of that, what that means, in order to, that contributes to, if you're going to do anything with unstructured natural language text, it helps you to understand the only empirical sort of observations that we can make about language in the however many years that we've been studying, linguistics in an empirical framework is that it varies and it changes. So how do we take that and use it to not, I don't want to, to not sort of normalize our data to the point where it tamps out the variety, but, how it actually, you can, meet that fact and bring that to the table in a collaborative sense. I think that's why, I think it's important to be able to have that sort of expertise with language.
Excellent. Thank you very much. We're going to take a break. And be back at 10 o'clock for the next panel. Thank you all. That was really